We are discussing IIT-JAM 2016 Modern Physics problem. Consider a free electron and a photon pH both having energy 10 electron volt of energy. If lambda and p represent wavelength and momentum respectively, then which of the following option is correct? So the momentum of electron is given by PE is equals to root 2 ME equals to 2 into 9.1 into 10 to the power minus 31 into 10 into 1.6 into 10 to the power minus 19 is equals to 17.04 10 to the power minus 25 kilogram meter per second. Similarly, the momentum of photon is given by PPH is equals to E by C 10 into 1.6 into 10 to the power minus 19 divided by 3 into 10 to the power 8. That is 16 by 3 into 10 to the power minus 27, which is 5.3 into 10 to the power minus 27 kilogram per second. Thus, P of E is greater than P of PH. Further, according to de Broglie hypothesis, lambda is inversely proportional to P, which implies lambda of E must be less than lambda of PH. Thus, lambda of E must be lambda less than lambda of PH and P of E must be greater than PH, so our option B is correct. A slit has a width d along x direction. If a beam of electron accelerated in y direction to a particular velocity by applying a potential difference of 100 plus minus 0.1 kV passes through the slit, then which of the following statement is or are correct? So, there are four statements. The uncertainty in the position of electron in x direction before passing the slit. This question is here incomplete. Is 0. So that is the first statement. So let us discuss this statement. Solution. Since the particle is moving along y direction, hence Px equals to 0. The uncertainty in the momentum before passing the slit is that is del x into del px. H cross by 2 implies x is equals to h cross by 2 to 1 by del px, which tends to infinity. That means statement A is incorrect. It is incorrect. This must be, instead of 0, infinity. The momentum of electron in x direction is h cross d immediately after passing the slit. The momentum after passing the slit along x direction is del x into del p of x h cross by 2d implies del px is equals to greater than h cross by 2d, or we can take it h cross by, this term is also greater than px, can be also taken as h cross by 2. So option B is correct. One can take it h cross by 2 or h here. So our result will be same order. Condition uncertainty should be greater than this. So h cross by d is also possible for this case. Now coming back to third uncertainty principle, third statement. The uncertainty in the position of electron in y direction before passing the slit is 0. Now that term cannot be 0 as we know it. Uncertainty in position along y direction is del y into del py is then h cross by 2 implies del y is equals to py, and that is greater than h cross by 2 root over 2me. So this term del y, it does not equals to 0. Option D. So option C is incorrect. The presence of slit does not affect the uncertainty of momentum in y direction. Uncertainty in momentum along y direction is given by del py is equals to root over 2me, and this is independent of position. Thus option D is also correct. Our answer are option B and D. A free particle of energy collides with one-dimensional square potential barrier of height v and width w. Which of the following statements is or are correct? For E greater than v, the translation coefficient for particle across the barrier will always be unity. For E less than v, transmission coefficient change more rapidly with w width than with v. For E less than v, if v is double, the transmission coefficient will also be double, and the sum of reflection and transmission coefficient is always 1. So one can see option with regard to option D, R plus T is always 1. So that option D is correct. Further, for E less than V, transmission coefficient is given by T is equals to 16 V0 square root over V0 into E minus V0 to the power 2 beta x, where beta is equals to root over 2m by h cross square V0 minus E. So one can see that T would rapidly change with respect to x. Here x, we can write it down W as well, with width rather than V, because V is the coefficient, not in the exponential term. So exponential term change more rapidly than the coefficient which is having V0 square in the numerator and V0 minus E0 minus V0. Further, if V0 is doubled, then that does not mean transmission coefficient will also be doubled. Transmission coefficient will change according to this relation. So this statement C is correct. C is incorrect. B is correct with regard to case E greater than V. If E is greater than height, that means question is saying transmission probability is 1, but we know it for this case there is some reflection of the particle from the barrier. So here also condition R plus T is equals to 1, not is satisfied, not T is equals to 1 and R is equals to 0. So thus option A is incorrect. Our correct options are option B and D. A particle of radioisotopes has a half-life of 5 days. In 15 days, the probability of decay in percentage will be the number of atom of radioisotope remain undecayed is n is equals to n naught 1 by 2 की power t into t by half, that is n naught 1 by 2 15 by 5, that is n naught by 8 equals to 12.5%. This means 87.5% atom will be decayed in 15 days. So answer will be 87.5. In photoelectric experiment, both sodium and tungsten metal were emulated by UV light of same wavelength. If the stopping potential for tungsten is measured to be 1.8 volt, the value of stopping potential for sodium will be. Solution. The energy UV light is given by E is equals to work function plus stopping potential. For sodium atom. ENA is equals to WNA plus EVNA, and for tungsten ET is equals to WT plus EVT. According to question, ENA is equals to ET, that means WNA plus EVNAS is equals to WT plus EVTS. So here WNA is 2.3 electron volt plus EVNAS equals to W tungsten is 4.5 electron volt plus 1.8 electron volt. So V would be 4.5 plus 1.8 minus 2.3 volt. V stopping potential of sodium, that will be equals to 4.0 electron volt. So thus 4.0 volt. Thus our answer would be 4.0. The de Broglie wavelength of a relativistic electron having energy 1 MeV is. We have to determine the wavelength, de Broglie wavelength corresponding to this relativistic electron. Solution. The energy of relativistic electron is E square is equals to P square C square plus M naught C square implies PC root over E square minus M naught C square का square. De Broglie wavelength is is equals to H by P is equals to HC by PC is equals to 6.6 into 10 की power minus 34 into 3 into 10 की power 8 into minus 0.5 square into 1.6 into 10 की power minus 30 is equals to 1.42 into 10 की power minus 12 meters. So our answer here is 1.42. X-ray of 20 kilo electron volt energy is scattered inertially from a carbon target. The kinetic energy transferred to the recoiling electron by a photon scattering at 90 degrees with respect to the incident beam is. So we have to determine the kinetic energy. Solution. Lambda Compton is 0.024 angstrom. Energy incident is 20 K electron volt and theta is 90 degree. The kinetic energy recoil electron is kinetic energy equals to E incident minus E scattered, where E incident. So the energy of scattered photon is Hc by lambda dash, whereas lambda dash is equals to lambda plus lambda c to 1 minus cos theta, which is equals to lambda is hc by e plus lambda c 1 minus cos 90, which is turning out to be 0.62 plus 0.024 is equals to into angstrom is equals to 0.644 angstrom. So energy of scattered photon would be 6.6 10 to the power minus 34 into 3 into 10 to the power 8 divided by 0.644 10 to the power minus 12 or 10 into 1.6 into 10 to the power minus 19. Solving this, we will get this result 19.21 K electron volt. Thus, kinetic energy of recoil K is equals to EINC minus ESC equals to 20 keV minus 19.21 keV is equals to 0.78 keV. So answer is 0.78 keV.